Hello, Mr. Ryan, right?
Yeah.
Okay, so you know the maze, right? The maze.
Yeah.
We talk about the maze problem many times, finding the path, shortest path from the entry to any exit, right? Or we can use the buffer search, use the depth search. So that problem, we are given the maze. The maze won't change. And we're given this exit here, and then entry here, right? Entry, exit.
What's that?
And then could be the path will be, somehow here. Okay?
What's that? That's a picture.
Yeah, I know, but the
Yeah, but there's no exit.
exit here.
Yeah, but you can't get to there because the door's blocked.
Okay, invert the image, okay? All the rest are filled, and then
That's
there's the
literally
path.
a super easy maze
Yeah, I know.
because there's no dead end.
Okay, so here, yeah. And then,
Wait, well, a kind of maze is there different type of mazes, and for example, this one, you put a gap there and a gap there,
yeah,
and then you can just see like that, and how I would do it, whoops, like that, and then I'll put some different ways, so it's not only one. So for example, I might put that. I might put like that.
okay, so,
So
yeah.
and these are the walls.
But also you need to fill in that, don't you?
Oh yeah.
I see. Okay, okay, that's interesting. That's good. Okay. Design an algorithm to generate a maze. Okay, so this is an ambiguous question.
Can it be like this? Can it be like this?
Oh, that's the simplest maze, okay?
Yeah, it's still a maze, but does that count?
Yeah, so that's a good question. That's good. So,
In a box.
yeah, I know, but
With a
so
lid.
we want to design a maze. This is an ambiguous question, so
Why
we
do
need
you
to
keep
ask
saying
the
that?
questions.
Why do you keep saying ambiguous?
Because I just said design an algorithm. I didn't say how, right? What is the requirement? And we need to ask a lot of these questions, okay? What kind of question would you ask? You need to know before you design the maze. Design an algorithm that could generate a maze. What kind of questions?
What type of maze does it have to be?
That's a good question. What type of maze? Yes.
Like this could be the one with just squares and the ones with paths.
Squares.
Remember?
Oh, this one, yeah? This is square. Everything is squares?
No. The one like this and then you have like...
Ah, okay.
Yeah, like squares.
Okay. Yeah, okay. So actually these two are convertible, right? Are convertible. Okay, so let's focus on this one. Yeah, it's a square. And okay, to simplify, if it's one, if it's a two-dimensional array, right? Matrix. If it's one, it means it's a wall. If it's zero, it means empty. Okay, you can walk through. Okay. Okay, so let's design a square maze with one, which is wall, zero is empty cell. And what's next?
So
Just type them randomly.
you just put it randomly, like pick or not pick.
Pick or not pick, yes. But pick or not pick, it could be a very random picture, right? Random square. How do you know if it's a maze?
We try it out
Try out what?
the maze to see if it's possible.
Possible.
Okay, so your solution is that to randomly generate one, and then we check if it's a maze, right?
Yeah.
That could be one way, right? So we generate random, whatever. It could be a maze or it could be not a maze, right? And then we check if it's a maze. If it's a maze, we return, right? Yeah? That's one way, but random thing is not guaranteed to be a maze. And it could be, you generate like 1,000 times and it's still not a maze. What would you do?
We delete some.
How do we delete some?
We delete a wall. We use Hulk smash.
Okay, so you're saying that we generate a maze, we generate a random square. If it's not a maze, we delete some walls.
Yeah.
Oh, that could work, right? Okay. This is one way, okay. Is there any easy way to do it? It's a square maze, and then we want the dimension, right? The rows and columns, right? We obviously need to know how big is the maze, alright? We need to know how many valid paths.
Yeah.
That could be one of the parameters. Valid paths. Sometimes a maze does not have any valid paths. Right? That could be still a maze. So can we think the opposite? Instead of randomly generating, which by the way is a good thinking, right? Valid paths. So can we think of this the opposite way?
We think of a path.
Yeah?
So we first draw the path.
Yes.
Let's say we draw a path like we can draw a path like that,
Uh-huh.
and then add some other stuff to it,
Add some other stuff. What other stuff?
like rules. And
Yeah, it's walls, right? So valid path, remember we are given this. For example, if you want to generate a maze with only one path, then we randomly generate this path, okay? Here. Right? This path, okay. This is the path, okay? And then that's it. We just fill the rest with
rules.
walls and okay, so this is a simple maze, but how do we make it like a maze?
We put some other paths like we put some other like
Yeah.
we can put another path to the end or put a dead end.
Good point. Okay, so how about this way? It's a similar idea. Okay, so we generate a path, but you are only asking for one valid path. Okay, let's generate a few more to spare. You know, it could cross, right? But for each other valid path, I put a wall randomly somehow to block it, and then that will work.
Yeah.
Is there a problem with this solution? Think.
Slow.
Yeah, could be, but it's efficient than this one, right? Because you don't know this one, you just say while true. Okay, I promise not to write the code, but this is the code, okay? And then generate, you know, the maze, generate, okay, maze. And then if maze is valid, then we return, right? Return maze. Otherwise, we keep doing this, right? Okay, so this one, remember, what did I talk about? So we generate a path, right? We generate a path. And then we generate a few other paths, but block it. Block it. When I block it, I block the middle. Block the same root of the original valid path. That could be a problem. So when we block it, we don't block the cross point. Okay? Make sense? Yeah, then that will work, alright? The idea is that we generate a valid path first, and then we generate a few other paths which we block it. Right? Depending on how many valid paths you want, okay? We could have two, and we generate two valid paths. Okay, and then we generate a few other paths which we eventually we're going to block it. Okay, and okay, so how do we generate a valid path? Right, this is the whole picture, and come back to this question: how do we generate a path? Here, a maze. How do we generate a valid path?
We put entrance and exit.
Yes, the entry and the exit are on the border, right? Remember, a few weeks ago we talked about that. The entry here, random, yeah, right? We allow the lots of generality, right? So I could just say the entry is on the top, right? If you want the entry to be here, 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 that's fine. I generate here and I rotate the matrix. Make sense? I rotate the matrix. Let's say the entry is on the top, and the exit could be somewhere on the border. Okay. Why do we need the entry to the top? I can say, okay, every time I can only walk down. I can only walk down, walk left, or walk right until it hits the boundary, right? So randomly, toss a coin with three possibilities: face up, face down, or neutral, right? So down, left, right. You randomly pick a direction. You go. Okay, when it hits the boundary, this is a valid path. Another way could be like that, right? And it hits this boundary, that's a valid path. Okay, his boundary, that's another valid path. Right, that's one way.
But what if it's this is the entrance, that's the exit.
No, we don't define the exit here. We just let it try, hit the boundary, which is the exit. We are asked to generate a path. We don't care. We are not saying, okay, generate a path from here to here. Then it becomes complicated because you are trying to find a path from A to B. Actually, that will work, but it's complicated. We want to simplify this. So we don't care where is the exit as long as it's on the boundary, as long as it's the boundary.
But what if the maze doesn't hit a boundary?
You can prove it always. Look, on the top, every time you need to walk down, walk left or walk right. You don't go up. So every time you can move. The first time it has to go down, okay? It can't go left or right, otherwise it will be on the top, right? That doesn't make like any sense, right? The first move has to move down, and after that, you can move left or right or down, right? You try this many times, you will eventually hit the left boundary, right boundary, or bottom boundary. Am I right?
But what if the maze just keeps on going in a loop?
What do you mean the
There's
loop?
a loop in the maze.
The loop?
A loop. And it never ends.
You mean here?
It just goes.
No, it never happens in this case. Because it never goes back. Am I right?
But you can keep on going right, left, right.
Yeah, that's good spotting. Yeah, that's what you mean, right?
Yeah.
Good point. Okay, so we can just use the hash table to remember the pixels we visited. Am I right? Yeah? Okay, so go down, go left. This pixel we have visited. We can't go back. And I only give you two choices. Right? Yeah. I saw you were talking about these go, like that. It never happens, right? But to be fair, we can add 4 directions as long as we have a hash set, right? So if we have this hash set scene table, which pixel we have seen, we can add a pointing up direction. But it depends on how you like the path to look like, right? It could be very curly, right? If you adding the top, it could be very curly and you come this way, right? That would work, right? Yeah. Okay, so to sum up, what have we learned today?
We learned about how to generate a maze.
A general maze. What kind of parameter we need to fit the computer first? What
Maze.
kind of parameters? How big is the maze? Yeah. How many valid paths you want it to be, right? These are the most important parameters. And then how do we generate a maze? What kind of algorithm? Eric, you mentioned a point to randomly generate a maze and then check if it's a valid. But the thing is, how do you check if it's a valid maze?
What is? So if you got a hash set and you can go up.
Yeah.
What happens if you go like this? Meow, 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 meow. Then you can't go anywhere. Is it?
Good point. That's a very good. That's a corner case, right? There's no path, right? So, okay, that's good. I didn't think of that. That's very, very good. Yeah, that's one situation. It could happen, but maybe unlikely to happen because every time you pick, this is the probabilities, right?
Dad was saying before that if you don't hit a boundary.
That's true. Yeah, very good. Okay, so let's get rid of this up, right? And just down, left, or right, and you will hit the boundary. Am I right? Yeah, you will hit boundary, right? That's very good. Okay, I didn't think of that. Very good. Very clever. Okay. Both of you, good job. Okay. And you said this one. How do you check if a matrix is a maze? You're given a square with the 1 and 0. How do we determine it's a maze? First of all, you find if there are entrance or exit in the border, right? Entrance, yeah. And then you try to find the route to the nearest exit. Finding the nearest exit to the entrance. You can use the algorithm. Breadth search. Depth search. Remember, we are given this maze. We are given this entrance, right? And we want to find out the nearest exit to the entrance in the maze. Right? We talk about this breadth search, depth search. The only difference is that we are not sure which entrance. We can just brute force these pixels, these places on the maze to see if it's an entrance. And then we just apply the algorithm. So this one is breadth search or depth search. Generate a maze, pick or not pick, right? You're saying each pixel has 2, 0 and 1, 2 choices. It's just quickly random generated. I don't know how efficient is that because the maze could be very big and then you randomly populating that and then you try to do this. That's a very good solution, very good thinking. And the other way is the opposite. We generate a valid path and then after that we just populate the rest, right? And that's it, right? Okay, so have you learned something today? Yes, good? Okay, that's it for today. Bye-bye.
Bye.
Bye-bye.